So for this video, we're going to be looking at the first method of rewriting these radicals in simplified radical form. And so first, what exactly is simplified radical form? Well, that is when the radicand has no perfect square factors in it, except for one. And there are no radicals in the denominator. So for instance, if I was looking back up here, I would see that 36, square root of 36, and square root of 25 are not in simplified radical form. And that's because when we come back up here, I see that 25 and 36 are both perfect squares. And that's because that 36, I can rewrite that as 6 times 6. And so I have a grouping there. So that means that the square root of this is just going to be 6. Same thing here, I'd have 12 times, 25, that's the same thing as 5 times 5. So I'm going to take the square root, since I have a group of 2, since that's the same thing as 5 squared, I get 12 times 5 here, which will end up being 60. So we're going to get some practice doing that with some other radicals. So there are really two methods that you can use. The first method is the perfect square method, and here it's going to have 3 basic steps. So the first step is to break the radicand into perfect square factors. And here you can use the perfect squares list to see which perfect squares divide into the radicand evenly. And then we're going to rewrite the radicand as a product. So rewrite this AB into this split up of the square root of A times square root of B. And then step 3 is we'll simplify each radicand when possible. So let's look at some examples. So here I have the square root of 20, and using method 1, I want to break this up and so that I have my perfect square factors broken up. So to do this, I would recommend looking at this list. So you might want to start at the next number that's smaller than 20. So like I can start at 16, and let's say if I pulled up my calculator, I can see if 16 divides into 20 evenly. I see it doesn't, so then let's try 9. Nope. Okay, and then we can try 4. Okay, and I see that 4 goes into 20 5 times. So I can rewrite 20 as 4 times 5. And so now I have my perfect square factors separated. And I see that 5 can't be broken up anymore. And then using my product property, I can rewrite that as the square root of 4 times the square root of 5. And then I know from my list that the square root of 4 is the same thing as 2. So my answer here would be 2 times the square root of 5. Okay, let's try the next one. So now I have 72. So when I come back to my list over here, I'll type in 72. The next biggest number from 72 on this list would be 64. See if that goes in there. Nope. See if 49 divides in there. Nope. See if 36. And I see that 36 does. I see 36 goes into 72 twice. So I can rewrite this as a square root of 36 times 2. And then use my product property, that's the same thing as the square root of 36 times the square root of 2. And then when I take the square root of 36, I find I get 6 square root of 2. And these are in simplified form because 2, there are no more perfect square factors in there. 5, there are no more in there either. Okay, let's try one last one. So now I have 128. So So we'll try the next highest number. So we see that's going to be 121, and that does not work. I can try 100. I see that does not work either. And I'm just going to keep on going until I find one that works. You may not have to do this. You may be able to tell right away which one goes in, but this is just kind of a foolproof way to do it. And so I see that 64 worked. So I come back here and I can rewrite this as the square root of 64 times 2. Same thing as the square root of 64 times the square root of 2. And the square root of 64 we saw on our list was 8, so this answer is going to be 8 times the square root of 2.